Hello and welcome to this pre-recorded event for feedback on the June 2015 GCE Mathematics Examination, Decision Mathematics 2. To help you get the most out of this feedback, you may wish to have the following documents handy, as they will be referred to during this session. You will need a copy of the unit specification for cross-reference of the topics discussed during the feedback session. You will also need a copy of the D2 June 2015 question paper and mark scheme. These will be of particular use later, when each question from last year's examination is discussed in detail. Finally, you will need a copy of the 2015 Principal Examiner's Report for D2, which should be read in conjunction with the feedback given in this feedback session. Finally, you may find it useful to have a copy of the D2 June 2013 question paper and mark scheme. These may be of particular use when marked candidates' responses are considered towards the end of this pre-recorded event. The key aims and objectives of this training event are detailed in this slide, and it is hoped that all these aims and objectives are clearly and concisely covered in this training pack. The A2 Unit D2 contains topics which both build on the content of the AS Unit D1 but also contains new content. D2 contains the following topics: transportation problems, allocation assignment problems, the travelling salesperson problem, game theory, further linear programming, dynamic programming, and flows through a network. Candidates need to be familiar with the material in and the glossary attached to the D1 and D2 specification. The examination will consist of one 90-minute examination. The paper will contain about 7 questions, with varying mark allocation per question, which will be stated on the paper, and all questions should be attempted. In particular, this unit will develop an understanding of mathematics and mathematical processes in a way that promotes confidence and fosters enjoyment. It will extend the candidate's range of mathematical skills and techniques and use them in more difficult, unstructured problems. Finally, this module will allow candidates to recognize and develop an understanding of how a situation may be represented mathematically, and give an understanding of the relationship between real-world problems and standard and other mathematical models, and how these models can be refined and improved. The number of candidates for this unit has once again increased, and in June 2015, 2,870 candidates sat this examination, which represents an increase of 6.2% on the number who sat the examination in June 2014. Further details are given on this slide with respect to the mean and standard deviation for the June 2015 paper, the minimum mark required to achieve each grade, and the percentage of candidates who were awarded a grade A and the percentage of candidates who were awarded a grade E or better. It can be seen from this slide that the number of candidates for this unit has increased year on year. It can be seen that in June 2015, the mean mark for this unit increased by over 6 raw marks, although the standard deviation stayed about the same. The percentage of candidates achieving a grade A and E saw very little change when compared to previous years. Comparisons between the percentage of candidates achieving a grade A and E for this applied module and those for the other two applied modules, Mechanics 2 and Statistics 2, can be seen on this slide. As a general introduction to the candidates' performance on the D2 examination for 2015, it should be noted that the majority of candidates demonstrated sound knowledge, and the paper proved to be accessible to nearly all candidates. Most candidates were extremely well prepared for the exam, and very few blank responses to questions were seen by examiners. However, it was evident in the final question that some candidates may have run out of time, and a few candidates either made no attempt or stopped midway through their solution. Most candidates were able to produce well-presented solutions, making excellent use of the tables and the diagrams given in the printed answer book. It was clear that there was sufficient material to engage the E-grade candidates, but also enough for grade A candidates to show their ability. Candidates need to be reminded that they must use methods of presentation that do not depend on colour, but are advised to complete diagrams in dark pencil. Candidates are further reminded that this is a methods paper, and they must make their method clear. Spotting the correct answer with no working rarely, if ever, gains any credit. Finally, poor quality of handwriting causes a minority of candidates to lose marks, particularly in misreading their own written numbers and letters, and basic arithmetic errors were seen in many scripts. You will now need access to the D2 question paper and corresponding mark scheme for June 2015. Question 1 was answered very well by candidates, as indicated by the fact that the modal mark was full marks, and this mark was obtained by nearly 40% of the candidates. Question 1, Part A, required candidates to perform one iteration of the simplex algorithm and to state the row operations used. The vast majority of candidates did this correctly, although a number did not change the basic variable from S to X in the basic variable column. And it was surprising how many candidates could not divide the pivot row by the value of the pivot correctly. It was pleasing to note that very few candidates this session pivoted on a negative value, but a significant number of candidates did not state either any or all of the row operations that they used. Part B asked for candidates to write down the new profit equation and the values of the slack variables. It was surprising the number of candidates who could not extract the profit equation from the final line of their table. Common mistakes included the use of two equal signs, incorrect signs attached to the coefficients of the variables, or omitting the value of 15. With regards to the request to state the values of the slack variables, most candidates knew what was required, although a number simply wrote down the values of all variables, or did not include the result that S was 0. Question 2 on the topic of game theory also provided a good spread of marks. And once again, the modal mark was full marks, which was gained by over 1/5 of candidates. Part A, in which candidates were asked to explain the term zero-sum game, was dealt with successfully by the vast majority of candidates, although a number overcomplicated their answer by talking about saddle points and stable solutions. A number incorrectly or inaccurately stated that each player, over time, would either win or lose a total of 0 points, or that the points scored would be 0. Examiners needed to see an argument that either the losses or gains of one player are exactly balanced by the gains or losses of the other player, or that the total points scored by both players is 0. Part B was answered extremely well by nearly all candidates, with the most common incorrect answer being -5 for the number of points scored by Greg. Part C required candidates to verify that there was no stable solution to the game. And at this point, it is worth re-emphasizing that this is a methods paper, and simply stating the value of the row maximin and the column minimax, with no corresponding working, is not a complete method. Candidates are required to state the 3 row minimums and column maximums, and then infer the row maximin and column minimax from these values. Finally, in this part, candidates are required to state that these 2 values, in this case 0 and 2, are not equal, and hence there is no stable solution. Part D asked the candidates to reduce the game, so that Greg was left with only 2 strategies, and to then write down the corresponding payoff matrix for Greg. Many candidates did not, in this part, write down the matrix for Greg, but left it in terms of the points scored by Rani. The most common error in this part was when candidates applied an incorrect dominance argument, and so removed column 1 rather than column 2. This remains one of the most common examination errors, where candidates incorrectly remove the column which has the smallest rather than the largest values, when considered relative to the other column. Part E required candidates to find the best strategy for Greg and state the value of the game to him. The vast majority of candidates correctly set up the 3 probability expressions for Greg's expected winnings, 1 for each of the 3 options available to Rani, although some made errors when simplifying these expressions. The graphical representation of these expressions was often very well presented, although it must be noted that a number of graphs were drawn without rulers, and some extended their lines beyond the axis, either before p equaled 0 or after p equaled 1. Examiners also pointed out that a number of graphs had inconsistent or missing scales on the vertical axes, or were very difficult to read due to the size of the graph drawn, which later meant that a number of candidates possibly failed to identify the correct optimal point. Candidates are advised that when drawing the graph, they should always use a ruler to draw the lines and axes. Next, they should indicate a clear scale, which in most cases should be 1 line for each unit. And finally, they should construct 2 vertical axes, with one at p equals 0 and the other at p equals 1. In most cases, the correct optimal point was identified, and the correct simultaneous equations were used to accurately find the value of P at this point. While many candidates correctly stated the value of the game to Greg, many stated that while Greg should play his option 1 with probability 3/4 and his option 3 with probability 1/4, they failed to mention anywhere in their solution that he should never play his option 2. Question 3 on the travelling salesperson problem was a very good source of marks for the majority of candidates, with nearly 2/5 of candidates scoring full marks. In Part A, candidates were required to use Prim's algorithm to find a minimum spanning tree for the network. And while many did this correctly, a significant number failed to list the arcs in the order in which they were considered, even though this was specifically asked for in the question. In Part B, nearly all candidates correctly doubled the weight of their minimum spanning tree to find an initial upper bound. In Part C, candidates were asked to apply the nearest neighbour algorithm to find a second upper bound. And while many correct responses were seen, a significant number of candidates, as in previous sessions, failed to return to the starting vertex, and so did not create the required Hamiltonian cycle. Part D asked candidates to decide which of the two nearest neighbour routes gave the better upper bound. This part was less standard than previous questions asked on this topic, although many candidates correctly calculated that the route starting at F would be 153 plus X. These candidates then went on to argue that if X is in the interval of 21 to 27, then 153 plus X would be greater than 166, which was the length of the route found in Part C. Examiners did note, however, that a number of candidates failed to accurately sum the weight of the arcs in the nearest neighbour route from F, or argued that the better upper bound was the greater of the two routes. In Part E, many candidates correctly found X, but in some cases, either their method or working was not clear. It was expected that candidates would explicitly calculate the length of the residual minimum spanning tree, and then add to this value the length of the two smallest arcs incident to A. Finally, this expression would then be set equal to 159, and the corresponding equation solved to give the value of X. Part F was generally done well by candidates, with the majority scoring at least one of the 2 marks available, following through from their earlier stated upper bound from Part D. Some candidates lost the final mark for the use of a strict inequality for the upper limit, and it was alarming to note the number of times examiners were faced with an inequality in which the upper bound was given as the lower bound, and vice versa. Candidates found question 4 to be relatively straightforward, with exactly 30% of candidates scoring full marks, and nearly 2/3 gaining at least 5 of the 7 marks available. In Part A, the first cut was nearly always given correctly, although errors did occur in the second. Part B required candidates to write down the maximum possible flow through the network, and while most did this correctly, a number gave the value of the largest, rather than the smallest cut from Part A. The flow along SB was almost always given correctly as 20 in Part C. Part D required candidates to explain why the two arcs, GF and GT, could not both be saturated, and many found this the most demanding part of this question. All that was required was a statement saying that the maximum capacity of the arcs going into G was 21, and so both GF and GT cannot be full to capacity, as the capacity of the arcs coming out of G was 26. When candidates are asked to draw a maximum flow pattern, they are reminded that there should be one and only one value on each arc, and that no arc should contain a flow which is greater than its stated capacity. Finally, it is advisable that candidates methodically check that the flow into a node is equal to the flow out of that node. Question 5 provided a good source of marks for the majority of candidates, with just over 15% of candidates scoring full marks, and nearly half of all candidates scoring at least 14 marks. In general, examiners saw some very messy and difficult-to-read solutions. And while the answer book contained a sufficient number of tables in which to complete parts A to C, a minority of candidates attempted to cram all these parts into just one or two tables, which often led to mistakes. The stepping stone method, in both parts A and B, was nearly always applied correctly, although some routes did not balance. However, a common and persistent error, which occurs with alarming regularity each session, is the significant number of candidates who incorrectly place a 0 in the exiting cell, when this cell must be left blank. It is a common error amongst candidates to fail to understand the difference between an empty cell and one with a 0 entry. As 0 is a number, it counts towards the entries in the table. Most candidates calculated the shadow costs and improvement indices accurately in parts B and C. And apart from the usual arithmetic errors, the most common error was the calculation of only 5, rather than 6, improvement indices. Finally, in Part B, a significant number of candidates did not state either the entering or the exiting cell. In Part C, the vast majority of candidates correctly calculated the 6 improvement indices, and stated that as none of these were negative, the current solution was indeed optimal. The cost of the solution found in Part B was nearly always stated correctly in Part D. Candidates found Part E, in which they were asked to formulate the problem as a linear programming problem, the most demanding part. Many candidates did not define their decision variable correctly, and very few correctly stated that X was both non-negative and the number of units transported from I to J. When defining the objective function, it is extremely important that candidates state whether this expression is to be maximized or minimized. In this particular problem, the expression should have been minimized. When stating both the objective function and constraints, many candidates did not use their defined variables, and instead used numbers in the subscripts, or incorrectly reversed their subscripts. A number of candidates incorrectly used the costs, rather than the value of 1, to form the coefficients of the constraints. it must be noted that those candidates who used sigma notation to form their constraints saved themselves a considerable amount of time and reduced the possibility of introducing subsequent subscript errors. It is finally worth noting the significant number of candidates who left this part blank. Question 6, the final question on this paper, was found to be both challenging and discriminating for a number of candidates, but it was clearly a good source of marks to many others. Part A was occasionally left blank, or the incorrect answers of minimax or maximize were often seen. With regards to Part B, in which candidates were asked to use dynamic programming to complete the table in the answer book, a number of candidates did not attempt this part, or made very little progress apart from completing the first stage. Many candidates did not carry the values from earlier stages into later stages, and a disappointing number of candidates used either the wrong arc or an incorrect value. Some candidates incorrectly completed Part B as either a minimax, maximum, or occasionally as a maximax problem. An alarming number of candidates failed to understand the method of dynamic programming and either worked forwards through the network from S to T, rather than backwards from T to S, or reversed the states and had the state and destination columns reversed. Finally, in this part, a number of candidates made it very difficult for examiners to follow their reasoning, and the values in the value column were often difficult to read. Parts C and D were often answered correctly, and candidates demonstrated a sound understanding of how the completed table should be used to find the maximum weight and the optimal route. All parts of E were answered well, although some candidates stated that H should be increased to 10, rather than HT. What follows are 3 marked examples of candidates' responses to a number of topics from the D2 unit. All 3 marked examples are taken from the June 2013 D2 paper. The first example looks at a response to the question on the travelling salesperson problem. The question can be found on this slide. You may wish to pause the recording for this and subsequent slides to allow yourself sufficient time to familiarize yourself with the content of these slides. This slide, and the next slide, contains the published mark scheme for this question. The candidate's response to this question appears on this and the next slide. The marks awarded to the candidate with appropriate commentary are given on this slide. The second example looks at a candidate's response to the question on further linear programming. The question can be found on this slide. This slide contains the published mark scheme for this question. The candidate's response to this question appears on this slide. The marks awarded to the candidate, with appropriate commentary, are given on this slide. The third and final activity looks at a candidate's response to the question on dynamic programming. The question can be found on this slide. This slide contains the published mark scheme for this question. The candidate's response to this question appears on this and the next slide. The marks awarded to the candidate, with appropriate commentary, are given on this slide. Thank you. And we hope that you have found this pre-recorded event for feedback on the June 2015 GCE Mathematics examination for Decision Mathematics 2 both engaging and useful in your future teaching of this unit.